Now let's come back to here. We say let operations in set. Let A and B be two non-empty sets. That is, there are elements to which you can base an argument on. Now, then number one, what do I define union as? Well, I will say the union set is a set of all F's such that X is in A or X is in B. I will write it as A union B. Now, how do I get it? You see, and you said B that notation bit. You see, it is set of all X so that S is in A or S is in B. But I avoid duplicates. When I duplicate, repetition of an element. What if the element is in A and B? Will I write it twice? That's duplicate. I already have 2. Will I write it again? No, 2 is 2. There's nothing like 2, 2. If there's a 2, 2, that will be 22. So you avoid duplicate, that is, we avoid repeating elements. That's how you get the union set. You have a set, you have another set, you want to get a union, bring the element that is either in the first set or the second set, but avoid repetition of elements. That's duplicate. Now the second one. So this is the set builder way of writing the definition. Very short, easy, and concise. Now, how do I define intersection? Well, you have to write it out A intersection B. And that is defined as set of all S, so that S is in A and X is in B. The element that is in the two at the same time. It's not like you are here, you are not there, you'll be in intersection. No. That is in the two at the same time. Do you get what I'm saying? That is the intersection of the two sets. How about set difference? Set difference. Let's say set difference between A and B. Set difference between A and B. Now, set difference is a set of all S so that S is in A, and because this is A minus, minus means not in or not an element of. So S is an element of A and X is not an element of B. S is an element of A and S is not an element of B. That's set difference. Set difference. Set difference. Set of elements so that X is an element of A. That is X to be the elements in A that are not in B. Elements in A only. Another way I can write this is that I will say this is what A intersection B complement. Elements in A and not in B. By the way, what's the idea of complement? Complement of a set is what is in the universal set, the bigger set, the main set that consists of all the elements under consideration that is not in B. That's what the complement is. So what do we mean by that? What is in A and not in set B? Do you understand? That is very simple. And then you can equally write B minus A. That would be the set of element that is in B that is not in A. So it's not like it's only a 4 thing that is possible. Let me quickly write that. How about B minus A? Well, the definition remains set of all so that S is in B and X is not in A. I'll write it as B intersection A complement, or A complement intersection B. Thank you. Now, symmetric difference. Symmetric difference. The concept of symmetry, the idea of symmetry, the word symmetry should speak something to your mind. Symmetry means a point of equality. Missing something? God bless you. Symmetry, a point of equality, a point where the left is equal to right. So when we are talking about symmetry, we want to come to a point that is actually very beautiful, and that is, we denote it with this: A symmetric difference, B. A symmetric difference between A and B. Now, and that is actually the set of all S, so that S is in A union B, and X is not in A intersection B. That is, I can write it as A union B intersection A minus, let me use minus A intersection B. Is that very simple? So that is the basic definition. There is not too much thing about it. Very easy. Know the definition. Play your game. You get it? As cool as it can be. Okay, let's add a question. They will play with every of these things. We do union, we do intersection, we do everything possible with it. So let's have a question. Now let's say A is set 1, 2, 3, 4. B is a set of all S such that S is even and less than 10. And then, okay, so 1, we want to find A union B. 2, A intersection B. 3, A minus B. 4, B minus A. 5, A symmetric difference B. Are you there? Now, the very first question is I want to change this set from set builder notation to style, tabular, or listing method. So how do we do that? They said S is a set of all X. So B is a set of all X such that X is even and less than 10. This should be even number less than 10. Well, I assume that to be positive even numbers. So in that word we have 2, 3, 4. Sorry, I said 2, 3. 2, 4, 6, 8. Less than 10. 10 is not in the set. So those are the elements in the set. But I'm better write it this way. Write it here. 2, 4, 6, 8. And now look at it. What is A union B? Don't forget the definition. Set of elements that is either in A or in B, avoiding duplicates, avoiding repeating of digits. So 1 is here, 1 is not there, but it should be in the union set. 2 is here, 2 is not here. Not because of right duplicate 2, I'll just pick 1, 2. 3 is here, 3 is not there, I'll write 3. 4 is here, 4 is there, I'm not duplicating 4, I'll pick 1, 4. Then 6, 8. That's the union of the two sets. Solution A. Now B, we have set intersection. The intersection between the two sets. What is here and here at the same time? Here and here at the same time. Looking at it here, 2 is here, 2 is here, 4 is here, 4 is here. So I'll say that's 2, 4. And then I A minus B. Now the elements that are in A that is not in B. 1 is in A, 1 is not in B. It will be in the set. 2 is in A, 2 is in B. No, it's not there. 3 is in A, 3 is not in B. Wow, 3 is there. 4 is in A, 4 is in B. So just 1 and 3. 1 and 3. 1 and 3. Now IV. How about B minus A? What is in B that is not in A? So the sense of set difference is not commutative, please. What I mean by commutative is that A minus B will not be equal to B minus A. No, it's never equal. Now, let's come back to the subject. Now, 2 is here, 2 is here. No. 4 is here, 4 is here. Well, 6 is here, 6 is not here. 8 is there, 8 is not here. So that would be 6 and 8. 6 and 8. Do I mean? And then finally, I guess, V, set difference. Of course, we told you that is A union B minus A intersection B. And that will be what is in the union set that is not in the intersection set. In the union set, we have 1, 2, 3, 4, 6, 8. And the intersection set, we only have 2 and 4. So now we all the elements here, removing 2 and 4. That is what? 1, 3, 6, 8. So I will drop a game you will play. Please do well to drop your answers in the comment section. The person that got it right, the first person that got it right, there'll be a shout out to you. At least in our next video, we shout out to you, or we at least commend your efforts in a very good way.